So first of all, welcome everyone, and thank you for joining today's webinar, MISRA C Compliance, Watch It Done Live. I'm Lavinia Battaglia, the customer service representative here at BUGSENG, and our speaker is Roberto Bagnara, who is CTO and chief scientist at BUGSENG, other than a very passionate computer science professor at Parma University. Not only, Roberto is also a member of the MISRA C working group and of the International Standardization working group of the C programming language. Before we start, as I said before, please note that you can write all your questions in the Q&A section on the left of the screen. Please do so throughout the entire webinar. So at the end, we can read the questions straight away and use that time to reply to as many as we can. All right, then, let's turn this over to Roberto.
Okay, thank you very much. Today, my task is rather complex, and to make it even more complex, Firefox crashed just seconds before connecting. So it crashed in such a bad way that I had to restart the machine. So I had prepared everything, and now I will have to do everything in front of you from scratch. So first, a few words about what happens today. So what is the special thing about today's presentation? We have had a very successful series, first series of BUGSENG webinars that for some people could be too theoretical. Okay, so we went through the main ideas and concepts behind MISRA C and C++, and what was missing is the practical side of things, and this is what I will try to convey today. So a few disclaimers. I do not use Eclipse, and I am very bad at it. And on top of that, now I will have to see how Eclipse was crashed during my forced reboot of the machine. The project that has been chosen had to be small and almost compliant to MISRA C 2012, because in 1 hour there is no way I can do much. In fact, the project that was chosen is the same we used in another webinar, and it was the project that is almost compliant to BAR C 2018. So by this fact, it is also compliant to a good part of MISRA C 2012. And as a disclaimer, I am using Eclair 3.8.0, so the forthcoming new release of Eclair. And there still are 140 violations and caution in the code, and we want to fix them all. So this is tough. And in order to do it, I will have to run a little bit, but I want to make sure you do not think that this exercise shows that you should do MISRA compliance this way. So you should always take the time to reflect, and you should not use a trial and error approach. So good training is a key thing. So let me now start. So I first, what happens here? No, I don't want to install things here. This is probably left from before. So first thing I have to do is to start Eclipse, which is here, programming Eclipse. And okay. So hopefully Eclipse remembers the project. Yes. I will do a clean, just in case. And now I will rebuild the project. For those that have attended the previous webinars, they know that Eclair works by monitoring the build. So whenever the compiler is called, the linker is called, the assembler is called, actually it is Eclair that is executed, and then the real tool is also executed as well. In order to make sure that Eclair analyzes exactly the same code that is seen by the compiler. So now I'll build everything. The analysis is going on, and I should see a window. Oh, this is what I didn't want to. This is what I. Okay, so it's here. It's in the wrong it's in the wrong place. So what if I do this? Okay, now it's in the same workspace, which is good. So here we have some statistics about the violations we have. We have 133 definite violations in this code and 7 cautions. So a caution is when Eclair is not sure that there is a problem. So it's the Eclair way of saying that maybe there are false positive in messages emitted as cautions. Whatever they are emitted as violations, they are definite violations. Okay, so another thing I prepared before the crash of Firefox was here. I wanted to show that, I don't know, that we can have the Eclair manual. Let me move this up because I don't want it while I do the rest of the work. And in the manual, there are also pointers to the MISRA documentation. So if I shift click here, then MISRA will be opened at the right page. So in this case, it is Directive 4.7. Okay, so now I am more or less at the point where I was before the crash. So let us start. Let us see what we have here. So we have, here is a table with violation, cautions, and information. So we don't want to see information for the time being. So let me hide all the information reports. We will talk about them at the end if there is time. So we have violations, we have cautions, and we have a lot of MISRA 2012 revision 1 guidelines for which the project is clean. You see it's there at the end, it's all gray. Okay, there are some information that are hidden for, but we have just switched them off. So there are no violation or cautions in many MISRA C. However, we have 140 reports to look at. I will start from the last one, which is not about MISRA C 2012. It is BAR C 2018, and I do so because it is Eclair that is informing us that there is probably a copy and paste mistake or a failure to update the documentation here. So there is a Doxygen comment where the parameter is described as num2, whereas it is indeed called n bits in the function declaration. So let me fix this because I want to, so let me enable here the Eclair plugin of Eclipse. So I want to fix this because I want I need the fact that n bits is actually the number of bits, so that an uint 8t parameter is enough. So let me fix this. N bits, it's the name. Okay, so now I save. I will frequently use shortcuts, even though I don't know them very well. So to save you from the fact I'm doing this, instead of going file save, I will use Ctrl+S whenever I remember, and to rebuild the project, I will use Ctrl+B. Okay, so now I type Ctrl+B, and so I reanalyze, and this violation is no longer there. So, okay, we still have 140. Okay, so now I wanted to point out another thing. So as you can see here, we are analyzing with respect to MISRA C 2012 revision 1. And this includes the amendment 2, which was published a few months ago, that allows for the use of C11. Why this is important? If I have also enabled MISRA C 2012 without amendments, the rule 1.1, and you see that we have violations. So in MISRA C 2012, before Amendment 1, only C90 and C99 were allowed. Okay, instead now with the publication of Amendment 2, so we can use also C11 and C18. So, and in fact, you can see that there are violations of MISRA C 2012 rule 1.1, but there are no violation for the MISRA C 2012 revision 1 rule 1.1. Okay, so let me now switch off this rule that was only enabled for this purpose. So let me comment this out because it is no longer needed. So let me save. Now I have to clean again because when I change the Eclipse configuration, of course, Eclipse doesn't know. And now I rebuild from scratch. Okay. And here we are. Okay. So we have Directive 1.1. What is this? This is a directive in MISRA C 2012, which requires to understand and document all the implementation defined behaviors upon which the program depends. And there are many implementation defined behavior. Now, I didn't check the number for C11. I remember by heart that in C99 there are 112 of them, and luckily we surely depend only on 8 of them, and possibly we depend on 6 of them. So how do we comply with this directive? So of course, Claire cannot know whether we know these implementation defined behaviors. Claire cannot know if we understood them. So, but Claire can be configured so as to provide evidence for this. So I have prepared things here in the configuration. I uncomment the evaluation of a file that I called GCC x86 64750 ECL, which is this file here. Okay, this is refers to the compiler I'm using. So let's take one of these implementation defined behaviors upon which we depend. This one, this is easy. How many bits there are in a byte in this implementation? So this is the configuration line for Eclair saying, looking that concerning this compiler, GCC, here is a regular expression matching the path for GCC. And concerning the standard C11, because this is a multi-standard compiler, the number of bits is 8. And this is a documentation that will be included in the final report. How do I know this? Check the manual gcc.pdf, which is this one, page 396. So let me, I was lucky. Okay, the number of bits in a byte is determined by the ABI. And now the ABI, if I want to make sure that I'm doing the right thing here, I should look at section 3.1.2 on page 11 of this other document that I have put here. It's a definition of the ABI. So page 11, and no, this is 14, page 11. Okay. So we have 8-bit bytes. This is written clearly here. Okay, so this is if you want, an annoying file to write, but we believe it's a proper way to comply. So you have a precise list of implementation defined behavior on which your program depends, and for those, you write this configuration where you have added in -doc lines the pointers to the documentation where the information is present. Okay, so now let us redo the analysis. So I should have probably saved, let me check what it is here. This one I have, okay, did I save? Project clean, because I have changed only the Eclipse configuration, so I cannot do an incremental build, which is what I would do if I only changed the code and not the Eclipse configuration. So now I build all. Okay. And okay, and so all the violations of Directive 1.1 have gone. Now there is a similar thing. So this directive requires me to explain how I minimize the runtime failures. Of course, I'm not the author of this project, so I don't know. I will simply show you what is a sensible thing to be done to comply with this rule. So I have prepared here another file, which I will first copy in the source folder. So now it's in the Eclipse folder, so I have to copy it here. Paste. I hope it works. Yes. And then I will add its inclusion in this, which is the main file. So sharp include dot MISRA underscore C underscore 2012 underscore something wrong here, 2012 doc.h. Okay, so let me save this. So I'm including it, okay? And this contains lines of documentation with an heading, okay? For example, here it says, documentation for MISRA C 2012 Directive 4.1, overflow. This is one of the possible runtime errors I can have. So the documentation has to be written. Here is an example, pervasive use of assertions and extensive test suite, okay? Another example, unexpected wrapping. Here in this project, in fact, wrapping is absolutely possible. It concerns unsigned integers, and it is absolutely wanted. Okay, so now let me rebuild. And so I have listed here all the things, examples of how one can comply to this. So one has remained. I did it on purpose. So just to show you that you cannot just put anything in this file. So there is no documentation about runtime checking for invariant violation. Why? Because here, it's written no documentation instead of documentation. And in fact, the comment said here to be written, change no documentation to documentation. So I don't know the project, as I said. So how can I check, how can I have confidence on the fact that invariants are respected? So for example, for one of the reasons that we have already seen, which I will copy here. So because maybe we have a lot of assertions, and we have a giant test suite that will exercise them all. So this gives me confidence on this fact. So now I fix this documentation. I save, I build, and this is gone. Okay, so we are done with this. We have now 4.6, Directive 4.6. It says you shouldn't use the plain integer types. You should use types that have an indication of signedness and of the number of bits, or you can use other types that are precisely designed to do a certain thing. So let us check the violations here. So let's move to Eclipse. Okay, so this is the first violation. So here we use it's a bit counter. So number of bits. We already know that this cannot be more than 8. So why don't we just? Why don't we just use uint 8t? This is certainly enough to hold the number of the bit. So let's go to the next report. Shift Control plus, Control Shift plus is okay. Here we have the number of bytes, or this is different. Okay, this is the length of this buffer. So what is the right thing to be done? Here we use size underscore t. Size t is available since at least C90. It is an unsigned integral type that is guaranteed to contain the size of any array. So it's okay. The only thing I have to make sure that we include stddef.h in order to make sure we have it. So let me include stddef.h. Okay, so this is done. Let me go to the next violation. So this is the number of bytes. So again, here we use size t. Are we in the same file as before? So yes, so we already added the inclusion. Control Shift dot. Next one here is the bit number. So uint 8 underscore t. Control Shift plus. Okay. Again, this is size t, the number of bytes in a buffer. Control Shift plus. Size t again. Size t. Control Shift plus. Okay, these are the declarations. For definitions, we have already fixed it. So I know both have to be fixed. Okay, so this, okay, there is another one. Oh, this is easy. strlen returns size t. So why not having size t here? Okay, so Control Shift S, I save everything, and now I rebuild. Okay, so, oh, fixed them all. So I refresh also here. So D4.6 is done. D4.7. This is a directive saying that if a function returns error information, then that error information shall be tested. Okay, so you see that we have violations for all functions that are in stdio. So let us look at them. Let us do some planning here. So here we have a violation. Okay, fprintf might fail, and fprintf and the other of the printf family return upon success, return the number of characters they have written, and they return a negative number if an error. However, what can we do here? So we are writing on standard error to signal the fact that the program has been misused. The number of arguments is not correct. So what should we do here? What can we do here is we go here and we deviate. Okay, so a fancy thing to be done is to deviate within Eclipse. Okay, we can do it in any other of the IDs that are supported by Eclipse. So I tag the area. What is it? No, sorry, I'm not in the right state. I want to go here. Okay, now I can tag the area. And then, Claire added a comment, which is a special comment. It says this magic spell -e greater sign means, hey, this is a special sign for a special comment that Claire will interpret, and it will put a tag here. Here I want a special tag. This can be configured here in Eclipse once and for all, but let me change it by hand. I want to hide the violations for MISRA C 2012 revision 1 Directive 4.7 in this line and one line, okay, and one following line. Now actually I want to exempt two following lines, and here I have to write the reason. So I am deviating, so the right thing to be done when you deviate is to explain why you deviate. I don't know, if we cannot print to stdr, there is little we can do besides returning 1, which is what happens. We return 1. We are in main, so this is one of the implementation defined behavior, by the way. So there is little that can be done. So, and now I am here. I want to draw, in order to save time, because it's already 11:28 here. So let me draw your attention on the fact that there are 2 MISRA guidelines concerning not properly handling the returning state of a function. One is this, Directive 4.7. It says if a function returns error information, then that error information should be tested. Okay, and how to proper test it is something that requires care and depends on the function. Claire knows about all the functions in the standard library, but this directive applies also to user code. So this might require proper configuration in Eclipse, because the function can return error information as a return value, writing to a global variable in many, many ways. However, there is another rule, which is 17.7, that says that the value returned by a function having non-void return type should be used no matter what. So here, Directive 4.7 is, by signaling this, is saying, look, you are not separating the erroneous values from the right values. In particular, we are not separating the negative values, which are the error encoding for this function. Rule 17.7 says you are ignoring completely, you are throwing away the value. So while at it, one way to comply to rule 17.7 is to cast this to void. Let me do this now in order to save some time. Okay, so I cast it to void as well. So I need to do this because as I explained. So now let us go back to Directive 4.7. We only fixed some of the we only fixed the first, where are we? The first 2 violations by deviating. Fixed means in this case we have deviated with a reason. Okay, we cannot print a standard error. There is little we can do. So, so let me go to the next. The next is 1. This is okay now. Okay, and this is not the other ones are not okay. Okay, so we have this printf this is the proper output of the program. So I want to comply really to the guideline, and to do so, I will declare here, I don't know, in 32t variable r, okay, and I will not ignore the value returned by r. I will store it by printf. I will store it in OR, and here I will check if it is negative. So if r is less than 0, then we are in main. I want to return 1 to the operating system. Okay, and let me copy this because I want to make this in many other places, in several other places. Say so R here and here. Okay, here is another one. Another one. And the last one. Okay. So I think I've handled all of them. And let me rebuild. And let me check. I might have inserted parsing errors. No, this is not the case. And in fact, I've resolved all the violations of Directive 4.7. I want to point out your attention that Eclair is smarter than you might think. So here, Eclair knows that for the printf family of functions, the erroneous values are the negative ones. And so Eclair will make sure that you separate the erroneous values from the other values. So if I change this code here, I don't have no time to do it now. Instead of checking for less than 0, if I write less than -2, Eclair will still complain. You are not handling -1 and -2, and these are erroneous values. Okay. Okay. Whereas by doing this, I am separating the control flow for all the erroneous values, and this is what Eclair checks. Okay, so 4.9, we have 4 violations. Okay, so Eclair is doing a smart job here. It is not only saying randomly whenever a macro is seen, you should use an inline function. Okay, so it actually checks that this can be done, and for this to be done, you say the Eclair method. It says all macro invocation arguments are R-value expression, because if this is not the case, you cannot replace this with an inline function. So in this case, since the code has been written with this macro in mind and I am in a hurry, I want to deviate. So I will edit common config. I have prepared here 2 deviations. I uncomment both of them. It says, look, concerning Directive 4.9, you hide 2 macros. One is called reflect data, and the other is called reflect reminder. Okay, so I now save. I have to clean because I only changed the configuration, and so what is it? Project clean here, and now Control B, rebuild everything. Okay, and so we no longer have violations for D4.9. I have not been very good, so to be very good, I should have written here, let me do it in any case, a documentation line saying why. Okay, I don't have a very good reason now because I didn't study the project in depth. As I said, the project has been conceived with these macros in mind. There are 3 different varieties depending on the configuration of the macro. I'm not sure that having 3 different inline functions would be cleaner, so I prefer leaving things as they are. So 7.2, it says that whenever an integer constant is implicitly unsigned, you should make it explicitly unsigned. Okay, so you see here the feature, one of the unique features of Eclipse is to show you the code after preprocessing, because here, initial reminder, you don't even know it is an integer literal. I can show the other areas, and now it's clear that it is actually an integer literal, and this is expanded in this macro. Okay, so I want to go here. So let me, okay, I want to go here to the macro definition, and you see there are several, there are three of these literals that are flagged. This one, which is now highlighted, and Control Shift plus the next one, which is this one. The first one is not flagged. Why? Because it is not implicitly unsigned. Okay, this is signed. This is implicitly unsigned. The following two are implicitly unsigned because they are too big, and only on those the MISRA guideline says you have to make it explicit. You have to show that you understand this is unsigned. Okay, so I have this was okay. There is maybe another one. Let me check. No, it should be whole. And so did I save? I don't remember. Let me save again. Let me rebuild. Okay. And okay, this was easy. So 7.2 has gone. Let me refresh. You see that it has gone. Now concerning 8.4. Okay, this is a guideline saying that whenever you define a function, a declaration should be visible. So this is what is the spirit of this rule, is to make sure that both the translation unit defining the function and the translation unit using the function see exactly the same declaration. So in order to comply with this, what I have to do is to go here and make sure that reflect.c includes reflect.h. Actually, reflect.c did not exist in the original project I have taken to do this demonstration. I added it to make the project slightly more interesting. So it's an artifact of my change. We'll talk about this later. Okay, so I have added the missing inclusion. I'm rebuilding now. I shouldn't do like this. I told you at the beginning. It's not trial and error that works. So I just do it to show you. Okay, so 8.7. This is a rule saying that function and objects should not be defined with external linkage if they are referenced in only one translation unit. Okay, so in fact, Eclipse is saying that for CRC init and other functions, there is only one invocation in main.c. However, this is a library. And the fact that now it is invoked only by main.c is because main.c is the test program. It is a test program we could even ignore in a sense. So what is the right way to handle this is to inform Eclipse about the fact that the public API of this library is crc.h, so the header file. So let me go here. I have prepared the configuration here. Okay, here I am tagging the source file called src in directory src / and the file is called crc.h. Why do I need the double backslash? Because this is an irregular expression, and without the double there's a double backslash in front of it. Dot would mean any character. Okay, so I tag. In this case, it's only one file. Of course, there are around public APIs that are more complex. And then I use this tag for the public files directive of Eclipse. Says, oh, look, all the files that have been tagged with API colon public, well, consider them as public files. Okay? So, and also there is a violation here that has to do with reflect. So reflect is only used in crc.c. This is true, but this time I don't have the excuse of the public API. Reflect.c was in fact static function inside crc.c. It was me who put it in a separate file. Okay, so in this case, I will simply deviate it here. I say, look, for rule 8.7, the function declaration of function reflect is exempted, okay, is deviated. So let me save. I've changed the configuration, so I have to clean the project. Now I have to build. Okay. So, and hopefully all the violations of 8.7 are gone. So we have now 8.13. I'm running a bit late. I'm sorry, but it's not so easy. So this is easy. So a pointer should point to a const qualified type whenever possible. Claire detects that indeed my name is never written to. So it's to comply, we just add const here. And since we are very, very good, we also restore the alignment. Okay. So save, build. Reload. Okay. Let me refresh here. So 10.1. This has to do with it's a series, very important series in MISRA C that has to do with the effective type system. Okay, so there are 8 violations. Let us look at them. Okay, so again, it is crucial here. Claire is saying, hey, here there is something that there is a context expecting an unsigned integer, and you are using a signed integer instead. Okay, where does this happen? Here. By looking at the preprocessed code, I understand what happens here. And this is actually a very dangerous violation because it is undefined behavior. Here, on this machine, on this implementation of C, sorry, int is 32 bits. So we are compiling the version where CRCT is 32 bits. Okay, and so here we are shifting. So size of CRCT is 4. It's 4 bytes. 8 times 4 is 32. Minus 1 is 31. So this is undefined behavior. Okay, this is undefined behavior, and it's something we should definitely take care of. So the problem is here in the macro top bit. So there are 2 solutions here in principle. So the first solution would be to simply add a U here. So to make this what is it? To make this one unsigned. However, the point is this: that I have looked at the code, and I know that this top bit is always used in conjunction with CRC_T type. So if I add a U here, I would solve this violation, but not others. So the right solution here is to cast to the one to type CRC underscore T. Okay. Okay, so this was the first violation. Let me look at the next. The next has to do with the same macro. So no. Okay. Let me go here. So this one, well, this is easy. So here we have assigned integer, and we want it to be unsigned. Okay, so let's fix this. In this case, a U is all what we want. Okay, because data is 8-bit, so it's okay. And let's look to other violations. Here we have another one. Okay, this is similarly dangerous. Okay, and why it is dangerous? Because n bits. So this expression, what is it? So no, I'm confused now. Oh, it's here. Okay, so n bits can be so let me check. N bits minus 1, so n bits can be 32, minus 1 can be 31, minus bit can be 0 because iteration starts from 0. And so the right solution here is to add a cast. One would be tempted to put a cast here. A cast to what? So reflection is uint32t. But if we put a cast here, we will be trapped by other MISRA guidelines that are very well conceived on this. So we shouldn't cast the result. We should cast the operand of the shift. So here is the cast we want. Okay, so time to reanalyze now. I don't know, did I change more than one file? Let me try to save them all. And then let me reanalyze. Okay, so there is still one violation. Oh, this is easy. So operands shall not be of inappropriate essential type. Here we are subtracting 1, which is an integer, from n bits, which is an unsigned integer. Okay, so here we want to add a u here. So the subtraction operator will only see unsigned operands, is what is wanted here. Okay, so this was 10.1. So let us look at 10.3. It's still something to do with mismatches. So here we have a multiplication operator that has essential type 64-bit unsigned integer. Okay, and whereas here this is used in the call to reflect, and the second argument of reflect, as Claire is informing us, expects an 8-bit unsigned integer. So to cut a long story short, where does this 64 bits come from? So it comes from here. It's size off. The size off operator returns size t, and on this machine, this is an unsigned 64-bit quantity. So what we want to do here is to cast this to uint 8t. Okay. What else? Let us check if we have other violations. So this is done. Okay. Here is another a similar one. We have XOR operator. You see the XOR there, So the left-hand side operand is 8-bit unsigned, and we have a 32-bit unsigned, which is what? It's this reminder expression that is 32 bits. So no, we want to cast this to uint. So I have typed it, but the file didn't change it. Why? Why is Eclipse censoring me? So the keyboard doesn't work. Do not tell me that Eclipse crashed. Oh. Let me check if things work. Which file is this one? It's crc.c. Okay, so where was it? It was this one. No, it was this one. I was probably trying to edit the preprocessed sources. Sorry, I'm start to being tired. So uint 8t. Okay, so done, build. And refresh. This was okay. So this is done now. We have now 10.4. Okay, so both operands to which the usual arithmetic conversion are performed shall have the same essential type. Here we have 32-bit signed versus, we are comparing an unsigned quantity with a signed quantities. What is the signed quantity is CRC table size. Is this one. Okay, so let's go here and let us change this to unsigned. And then the other one, I can see it here, is bits per byte. Okay, so this is also unsigned. Okay, so do we have other violations? These bits all due to the two macros are okay. I see another one here, which is different. Okay, is arg count is 8-bit unsigned. We are comparing it with 32-bit signed. So what is it? It's here. Arg CNT is declared of type uint 8t, and whereas we are comparing it with argc, which is of course of type of signed type. You know, it's int, so we remove the u here. So int 80. I think that the argument count is stopped at 2, so it fits. And this was, I think, the last violation. Let me save everything, build. Ooh. And okay, so I still have violations here. Oh, right. Okay, so let me, oh, these are trivial. So let us fix them all. Here, bit is unsigned. I am comparing it with a signed. So let's put a hue here. Next one. Here is what is the problem here? Okay. Same thing here. Top bit. What is the problem with top bit? remainder top bit and width. Okay. Okay, so here we want to have a U here, and okay, let's reanalyze now. Okay, so this is done. This was 10.4. So for 10.7, we have only one violation. What is this? Okay, so we have left shift operand as essential 8-bit unsigned integer type and standard type int. So this is because uint 8t, there is an integer promotion to int, and so you see it's uint 8t, but remainder is larger. So here we want to add a cast to CRCT. Why? Because remainder is of type CRCT. Okay, so here we want again we want to cast not the result of the shift. We want to cast the argument of the shift. CT, yeah. Okay. So let me rebuild. There is no way I can do it in 2 minutes, but probably in 10 minutes I can do it. So 10.7 was done. 12.2. So okay. So here we have a shift, and Claire says, "Look, I'm not sure, but I cannot exclude the possibility that here you will shift more than 31." So here is the point, okay? And you see there is a comment here. Note, for efficiency's sake, n bits is not verified to be less than or equal to 32. So in fact, Eclair is signaling something that is a real possibility. So we don't know this code. We assume that if this was done by the author, is because of this checking for n bits to be less than or equal to 32 is crucial for speed. So I will blatantly simply say C note above here. Okay. So, okay, I saved, I reanalyze, and this is not gone. So I did some mistake, maybe. Tag. Sorry, I didn't. Okay, I didn't configure here. So anyway, window preferences, Eclair. You see this tag here. I should have, since my intention was to use it only for hiding. The mechanism is much more general. To speed up things, I could have configured the plugin, the Eclipse plugin, in a different way to automatically put hide here. And so now I think we'll be okay. Yes, 12.2 is gone. So 14.4. Okay, so the controlling expression of an if should be a Boolean. And in this, these are not Booleans, so we fix them all in a very trivial way. So let us start with the first one. Where is it? I clicked in the wrong place, maybe. Okay. So, okay, I want it to be a Boolean. So I take the value and I compare it for difference with respect to 0u. 0 unsigned. Control Shift dot next report parenthesis difference operator 0 unsigned. Control Shift dot should be the last one parenthesis difference operator 0, U. And this was the last one. So save, build. Good. So we have a 15.5. Actually, one problem, so it's an infamous rule about having more than one exit point. So a rule that many people doesn't like. And one instance of this was already present in the code we started with. So this return 1. And I have added other violations you see here. I added them in order to do some handling for the case the printf family function return a negative value. So indeed, here we are in the main and it's late. So we deviate. We deviate for the for the function main. So the function main, we say to Eclipse, look, for rule 15.5, the reports that are all in such that all their areas are in the context of the main function, they are hidden. Okay. So let me not reanalyze now. We will see at the end. We have a few more rules okay. A function parameter should not be modified. Okay, and in fact, here it is, data is a parameter and it is modified. So this is not good. It's not good because it is better if the programmer can always assume that data is the value that was passed. So how do we comply? So we introduce a working copy. So first we rename refactor renames this to X data. I not this one. And we add a working copy called X data, which is initialized with data. Okay. So let me check. Data is passed. We initialize X data, and then we work with X data. Okay. I have also changed the configuration before, so let me clean, let me build. Okay, so 15.5 disappeared, and also this one, which was 17.8. Now we have still a few violations. Okay. Okay, so there is a variable which is called reminder. However, Eclipse informs us that reminder is reserved as a function name for the header math.h in C11. So we cannot use this. We have to change it. So let us change this. So I always forget. It's what is it? Sorry, it's I am sure it is under my eyes, but I don't. Refactor and rename. Reminder, we cannot use it. So let us call it residue. Okay, which is also used in mathematics. German-speaking people maybe would prefer REST, but REST is not so much used in mathematics. So let me check. Here is another, in another function, we have the same thing. So refactor, rename, and we want to call it residue. Okay, let me see if there are other occurrences. No, I think it's okay. Let me now reanalyze. No, there was another one here. How could this escape? I don't know. Okay, so for refactor rename and residue. Okay. Okay, so this is fixed. Now we have 21.6. We are at the end. The MISRA guideline has to do with the fact that we shouldn't use the standard library for the input-output, so stdio, whereas in main.c we use it. So, well, as I said, main.c is not part of the library. It's a small program just to test it. So what we will do, we will simply deviate. And this time we deviate all the occurrences that are located in the source file src main.c. Now I save all and I rebuild everything. No, I didn't. I should clean because I have changed the configuration. Sorry. Okay, let me build everything. Okay. Zero violation. So we only have 8 information reports and no violation, no caution. We started with, I don't know, 140. What was it? So now let us look at these information messages that we have hidden before. Who knows? Okay. So we have, no, sorry, I want to, okay. So explain is an information. It tells me about the configuration, how I configure the system. For example, okay, I have tagged this file with API public, and this is written in English here. Okay, so it's the configuration of Eclipse translated into English. Okay, so then I have 4 information messages for D4.4. It's the guideline that says section of code should not be commented out. In this project, there is no commented out code as far as Eclipse found. And however, there is code that is not compiled. This is an information, so maybe we are not interested, but just to make sure that, yes, we compiled the version for CRC32. And so these 2 parts in yellow that are used for 2 other varieties of cyclic redundancy check have not been compiled. So, okay. And another thing, the last thing I wanted to show you is that, okay, so, this Eclipse is looking at, it is informing us that this function we are ignoring the value, so it's just an information, just to make sure that we are aware of this. We did it on purpose, of course. And then this is very interesting because it says, look, you have put 2 suppression in comments in the code, and they are both used. This is another feature which is unique to Eclipse, which allows us to no longer be so negative about deviations put in the source code, because if this deviation was not used, Eclipse would warn me. Okay, now it tells me you have 2 and both are used. If there are some that are not used, Eclipse would warn me. And this is something that happens. It happens because you know how it works. Comments are not always kept up to date with respect to the code. You change the code, you do not change the Eclipse comment, and then you may be in trouble. So we started with 140, I think, between violation and caution messages. In slightly more than 1 hour, we have reduced this to 0. Of course, the success of this is due to several factors. So I have cheated. So I've prepared something in advance. I studied the violations in advance. However, it should be clear to you that in order to have a performance that is, I mean, reasonable, you need good tool, first thing, and you need a good training on what MISRA is about. So I have spared you the experiences from trying the wrong solutions. So for example, you see, when we met the undefined behavior thing, one way to resolve it would have been to add a U after one, so one unsigned. However, later in the project, we would have discovered that we would actually need a cast to CRCT. Okay, so I hope the thing was interesting and useful to you. Thank you. If you have questions, I will be happy to try to answer them.
Thank you, Roberto. We made it to the end. Well done. So we've got a couple of questions. First, if I am in doubt about a rule, is there a way I can quickly access the relevant documentation? I think you showed this before.
Yeah, I have. Incidentally, I've showed this at the very beginning because yes, I had this crash. So you see, in the if I click, I don't know, if I go here, the number of enabled services. So say, I don't know, this rule. Okay. So I am brought to the Eclipse user manual. Okay. Now the version I'm using of Eclipse is a version that contains a lot of things. So it contains the full Monty. So basically 2,000, 3,000 rules implemented, not just MISRA. So it's a document that is very long. So here I can go to this manual page that tells me what are the kind of extensions that Eclipse can recognize and how can you justify them if you want. And if you click on this small ants here, and you have installed okay, you see here, rule 1.2, you will be brought to the right page of MISRA. So one thing that I take the occasion to say, so this copy of MISRA is licensed to BUGSENG SRL. So I don't want people to think that with the tool, you get also a copy of MISRA. So what happens is that you license a copy of MISRA from MISRA, and then you install it in a certain place in the Eclipse installation, and then Eclipse will use the PDF if it finds it there. Okay, so there are most coding standards are subject to licensing restrictions. For example, BARC 2018, you can download it for free, but we cannot redistribute it. So you have to go to the BAR group website and apply for it. You will get it for free.
Okay, thank you, Roberto. Eclipse can be used with TI CCS.
So Texas Instruments, yes, it's a variant of Eclipse. All the we support, we believe, all the variants of Eclipse around, and Texas Instrument CCS is one of those. We have tested with Eclipse derivatives back to 2009, and we found no problems. So.
Okay. What about unused obsolete suppression comment and or deviation in configuration script? They are a big problem with our current code-based Bayesian tool.
Yeah. So yes, that's what I was saying before about this CBS service. that is here. So if there are comment-based suppression in the source code that are never used, for example, if a comment says ignore a violation of rule, I don't know, 15.5 in the following lines of code, and if there are no violation of that rule in the following line of code, you will get a message. You will be told, look, you have this suppression and this is never used.
Okay, so thank you very much, Roberto, and thank you, everybody. I hope you enjoyed this slightly different format. If you did, you will also like our coming series of very short, very practical video tutorials. We will start uploading them very soon on our YouTube channel, but we won't be announcing their publication. So if you want to know when they are available, please subscribe to our channel so you will receive a notification from YouTube itself. Also, in case you didn't notice, this was the last webinar of this series, but no panic. We will take a short break and start a brand new series in June. If you have attended at least one webinar of this series, you will probably receive an email. But to make extra sure that you received the new full schedule, please subscribe to our monthly blog. You can do so by writing your email address at the bottom of every blog in the blog section of our website. Lastly, if you want to know what we're up to more in general, a good place to go is our LinkedIn page. It would be great if you would follow us there as well. All right, then, if you have more questions or if you'd like further information, drop us an email at info@bugseng.com. We truly look forward to hearing back from all of you. So thank you again for joining us today. We hope to see you all next time. Goodbye, everybody.
Bye-bye.